if we have the gravity field of the Earth like that, or then we have ellipsoid which has the best fit to this. Then this ellipsoid gives us a gravitational potential, but this time this ellipsoid is smoother with homogeneous mass with the same rotational rate of the Earth. Therefore, this will be much simpler than the gravity field of the Earth, and it's smoother. It's called normal gravitational potential. So, therefore, for each point outside, we can define two potentials. One is the real potential, one is the gravitational potential. I define a new quantity which is called disturbing potential. Is in fact the true potential minus the normal potential. That's called disturbing potential. So if this ellipsoid and the normal potential, gravitational potential, is in fact an average value of the true gravitational potential. And when we remove the average from the potential, it means that we are actually working on residual gravity. Residual gravitation, and disturbing potential is the residual gravitational potential. So it's an average which is taken, which is removed. So based on this T, the disturbing potential, we can define different quantities. For example, the first and very well known is the gravity disturbance, which is in fact minus T Bru. It is the first radial derivative of the disturbing potential. We can define geoid, which is T over gamma. Gamma is normal gravity. This formula is called Grun's formula. And we can determine gravity anomaly, which is derivative of this potential minus 2 over RT. So three important quantities can be defined from the disturbing potential. And this is gravity disturbance, Grun's formula, and gravity. The simplest one is this N, geoid height, and this connection with the potential.